Дорогие гости, я рада приветствовать вас сегодня здесь.
Esteemed guests, I am very happy to welcome you here and Mayak Academy that is named after esteemed academician, historical figure, Dr. Sakharov. We are witnesses of huge historical shifts and tectonic shifts in all sides of our life, and we have a lot of breakthroughs that really change the life of entire humanity today. And today we are going to talk with our esteemed guests that are really thinkers of their lifetime about how to turn all of the changes into our favor. But before we start, we are joined by Alexei Likachev, Director of State Corporation Rosatom. Please welcome. Dear guests, dear colleagues, I'm very happy to welcome you at the second International Forum Dialogue, Science for Peace and Development. Today, the world is encountering a whole series of challenges. I shall outline the major ones: climate change and environmental problems, rising scarcity of natural resources, overpopulation and inequality. Scientific societies and scientists all over the world are searching for the answer for these challenges by suggesting solutions in energy sector and medicine and high tech. All of these things that ensure sustainable future for our world. Esteemed guests, atomic science is contributing in resolving these challenges. Among our priorities, we have two-component atomic energy and closed fuel cycle, development of small nuclear generation, and research in nuclear synthesis and plasma technology. We are participating in international scientific projects such as constructing international thermonuclear experimental reactor. We're also studying thermodynamics, acoustics, metal science, radiochemistry, and physics of plasma. With that in mind, we're ready for the future of nuclear science. For that matter, in Sarov, we built a center of physics and mathematics, and our goal is to turn it into world-class center. And in the branch of Moscow State University that is located there, the future generation of young scientists are studying there, and it is their fate to make a breakthrough in the next day in AI, in quantum computing, in physics. And very soon, we are going to have mega science installations and specialized scientific labs over there. Esteemed colleagues, we are sure that scientific research should not be held by boundaries of political conjecture and far-fetched limitations. Circulation of talent is a global trend that we, of course, are wholeheartedly going to support, and we are ensuring that this center of mathematics and physics will become a center of teamwork of best sciences of all over the world. This approach allows us to achieve great results and make them for the benefit of all humanity. Esteemed colleagues, it is very symbolic that our international forum is held in Mayak Academy, that is named after Dr. Sakharov. He was a man of huge talent, and he really felt the responsibility of scientific mind for everything that is happening in the world. So let his experience, as his achievements, become inspiration in your search for answers to global challenges of today. I wish you luck, friends and colleagues, and have a fruitful day. Thank you, Mr. Likachev. Now, I would like to invite to the stage everybody to today's discussion, and it's going to be very interesting and engaging. And on the website scienceday.rosatom.ru, where you can watch this discussion live, and since we have an international discussion, it is in hybrid mode, both in English and Russian languages. If necessary, we have a function of simultaneous interpretation. And now, allow me to introduce our speakers. And for that, I'll switch to English.
We are now ready to introduce our speakers, and I'm delighted to do this right now. So today we are joined by Dr. Adriana More, theoretical physicist, director at the Foundation for Space Development Africa, and founder of the Proudly Human Research Project. Anatoly Krasilnikov, Rosatom's Atomic Energy Corporation head for its ITER project center. Also joining us via video link, Alexey Fedorov, head of the Quantum Information Technologies R&D group of the Russian Quantum Center. Dr. Dong Lian, Deputy Secretary General of the Chinese National Committee of the International Society for Digital Earth, Assistant Director General of the International Research Center of Big Data for Sustainable Development Goals, and Deputy Secretary General of the Digital Belt and Road Program. Gabriela Bailas, PhD in particle physics and science communicator. And our esteemed guest, Ancha Baranova, PhD in molecular biology, professor at the School of Systems Biology, George Mason University, and member of the Scientific Advisory Board at Atlas Biomed Group, Moscow. Dear guests and participants, since this is a discussion, I invite everyone to be engaged in the conversation at any time soon. So feel free to offer your thoughts on the ideas presented by our colleagues. So feel free, do not hesitate to debate. And now we're ready to open the discussion with our first question to Adriana More. So we leave now, Adriana, in a very difficult time, a time of transformation. As humanity enters a new historical epoch, we find our civilization unbalanced. Population growth is driving consumption, which in turn exacerbates already dire environmental problems. Adriana, your research project, Proudly Human, involves a series of experiments to create housing in some of the most extreme conditions on Earth. This is done as a way to prepare humans for life on the Moon and Mars. Do you believe that our home planet is getting too small and cramped for its inhabitants?
Thank you for the question, and it's an interesting time to visit, so thank you for the invitation. It's great to be here with you. So it is an uncertain time that we live in. There's a lot of anxiety about the future. But one thing we can say for sure is that things are not going to get less extreme, right? This we can guarantee. So what does this mean, and what does it have to do with space, and what does it have to do with poverty and inequality? I'm from South Africa, so how to align space exploration with addressing issues like inequality and poverty are very close to my heart. Let's start by talking about the space developments that happened during the pandemic. I think we can be proud as a planet to have sent 3 successful missions to Mars during 2020. The UAE sent the first successful orbital attempt. We saw China in the first attempt landing a rover on the surface, and of course NASA sending another rover to the surface. All 3 successful during the pandemic. So this is an exciting time for exploration beyond Earth. We are breaking new frontiers in terms of participation from different regions, as well as a record of traffic, let's say, to Mars during the pandemic. On the other hand, we have billions of people without clean water, clean air, billions of people without nutritious food, billions of people without access to reliable power and communication systems. And in the current technological era, access to power and communication systems are actually a fundamental requirement to participate in today's society. So, what can we do to address these challenges? Can we address them at the same time? And I established Proudly Human in 2019 with the idea to combine some solutions to these challenges. Now, whether we are thinking about humans living on the surface of Mars, the dream, right, of living on another planet, a personal dream as well, maybe some of you share this dream, whether we are planning to go back to the moon, this time to stay there and do research there on a more permanent basis, or whether we are thinking about 1 million refugees in the desert, or whether we are thinking about millions of people living in overcrowded city centers. The fundamental requirements to participate in communities for humans are the same: shelter, power, water, food, communication systems. So the systems that we envisage, the systems that we plan for the surface of the moon, for the surface of Mars, this is super exciting, especially for the younger generations. We can in fact align these goals with providing safe housing, clean water, clean air, food, and power and communication systems for people on Earth. So Proudly Human endeavors to align these goals by taking teams of experts, researchers, engineers, artists, psychologists, into the most extreme places on Earth, like the middle of the desert, where we focus on water management. In Africa in particular, water management is a critical issue now with climate change. Then we will go to the polar regions in the Arctic Circle. Energy management, of course, critical. From solar power, not so useful, to wind power, to hydrogen fuel cells, to biofuel technology. Then we will go under the ocean. So this is an environment where the external atmosphere is not breathable. So this is close to being in the space station or beyond Earth. In each of these three locations, we will demonstrate technologies, but importantly, human spirit, community spirit, in order to demonstrate the kind of technologies we need for a future on Earth for all 8, 9, 10 billion of us, but also for that most exciting and inspirational goal of living beyond Earth. And perhaps you're interested to join some of these extreme environments. You can check our Proudly Human website. We will also document the experience for those who would prefer to watch from home. So perhaps that's enough from me for now. Thank you for the question.
Thank you so much. That was very exciting. And now we're going directly to Beijing. Joining us now is Dun Lian, professor, Assistant Director General for the International Research Center of Big Data for Sustainable Development Goals, and Deputy Secretary General of the Chinese National Committee of the International Society for Digital Earth. Welcome, Dr. Liang. Sustainable development is a philosophy that humanity has embraced since the Club of Rome was founded. The UN Climate Conference, COP27, is in progress right now, but we don't yet know its results. Last year's COP26 summit failed to produce any breakthroughs. Year after year, we repeat the same mantras about sustainable development, and yet so little is being done. Could you tell us more about the concept of digital Earth? How would it address humanity's global challenges?
Thank you, moderator. Yeah. There are several reasons why we are facing challenges in achieving sustainable development. So first, the concept itself is quite challenging, as we have to balance the three dimensions inherent within it. That is the economic, societal, and environmental aspects that span across all cultural and socio-economic diversity. The UN, through its various programs and through multi-stakeholders engagements, is working to develop consensus and agreement. Secondly, there are capacity challenges where technology and science have an important role to play, and researchers and scientists are working to find new solutions and innovations to facilitate global progress towards sustainability. So similarly, building upon the role of science, we need information and data to understand the complex systems and our impact on the natural environment, to develop sustainable strategies and solutions. So Digital Earth is a concept developed by global innovation to study interconnectivity of the natural process. Digital Earth science seeks to create a virtual representation of the Earth to develop an interactive model that is multi-scale, multi-temporal, and multi-layered, and can provide comprehensive information for decision support and the policy development process to help policymakers and decision makers to make informed decisions with a consensus through reliable and scientific inquiry in achieving global sustainable development. Thank you, moderator.
Thank you so much, Dr. Liang. And now I would like to stick back to Adriana and get back to the question of scarcity of energy resources. It is one of the most challenging problems right now, and this problem we will face in the nearest future. Hydrocarbon reserves are being depleted. Besides, the extraction and consumption of these resources puts a huge stress on the environment. So on Earth, resources are limited, but if the future of humanity is in space, where will we get all that energy? Are we going to harness solar winds, create solar power plants, or perhaps thermonuclear reactors? What's your stance on that?
So let's go back a step and consider our unique planets in the solar system where we are currently confined. We have the sun, utilizing fusion technology, let's say hydrogen, the most abundant element in the universe. Let's look now to the surface of our planet, warmed by the activity of the sun, maintaining liquid water on the surface, the only planet we know of with liquid water maintained. And did you know that 10% of your body is as old as the universe itself? The hydrogen, all of which, the majority of which was produced in the Big Bang, has been around for the entire duration of the universe. The hydrogen inside the water molecules inside your body then is as old as the universe itself. Magic. So, we have the resources. We are in the universe, and the universe is in us. And we live on a unique planet where these resources are available. The question is, how are we managing these resources? And for me, looking to hydrogen, if it's good enough for rocket fuel, it should be good enough for other purposes. So its abundance, I think, tells us to invest more into understanding the use of hydrogen for power systems on Earth. Beyond Earth, let's take a quick history. We already had the first battery-powered satellite, Sputnik, 1957. That amazing realization that we have put technology in orbit around our planet. The next year, we already had the first solar-powered satellite. 1961, we already had the first nuclear battery-powered satellite. So on Earth, I believe we have a rich amount of resources. We need to manage these resources better. We have abundant resources. The resources and the restriction on them are perhaps not the problem. The management systems that we focus on are perhaps the problem. If we have a system that encourages consumption, we have a materialistic-based culture. If we continue to grow our population and we remain on one planet, then we have a problem. If we want to leave Earth and explore the solar system, I believe the array of satellites we launched 50 years ago already gives us the tools to understand how we can explore beyond Earth. So I think that the inspiration, the dream of looking up at the night sky and imagining exploring and living there is what encourages us to keep dreaming, to keep being curious, to keep doing science. But while on Earth, let's also remain practical and try to think about how to deal with our resources more efficiently. And to bring it all together, I think space is a great place to practice resource efficiency. Many of the technologies developed for space can assist us in the challenges we face on Earth at the moment. And so we can do both. We can address resource scarcity, we can address inequality, and we can address the human need to explore and dream all at the same time. If we remember to, be grateful for this reality we find ourselves in. Stay curious.
So that sounds promising to me. So, Mr. Krasilnikov, thermonuclear synthesis will allow us literally to light up thousands of artificial suns here on Earth, which will provide a source of cheap, pure, and limitless energy. When will this miracle happen?
You know that we are now in our way to create ITER, experimental thermonuclear reactor, in France, and 35 countries, 7 partners participate in this activity, and idea of this machine is toroidal camera with magnetic coil, tokamak. And why I mentioned about this? Because Andrei Dmitrievich Sakharov invented this magnetic trap and invent this arrangement of magnetic field to keep plasma in a single space. And the question is when this development will provide result and when we will have a reactor. We expect that major physical problem will be studied during next, let's say, 15 years, and around middle of this century, several countries plan to construct demo reactor. Demo means demonstration thermonuclear reactor. And this is the goal, this is a realistic goal, this is goal of our US, European, Japanese, Chinese partners, and also our goal of our Russian fusion program. And we are very optimistic in this field, and one time, maybe 40 years ago, when people asked academician Artsemovich, who was head of Soviet fusion program, when fusion will happen? And the answer was, when people really require it. And looks like now we really need infusion because this totally new type of energy production, without restriction with fuel, without any danger, and it could be applied in every space, in ocean, in space, on the Earth, and provide required energy for people. So my answer is that in the middle of this century we will have it.
Thank you so much. We still have time. Now I would like to stick to our guests, to one of our guests, to Gabriela. Gabriela, hi. We're happy to have you here in our discussion. You're studying particles that go by the romantic name charmed mesons and can be both matter and antimatter. I know that even a tiny bit of antimatter can produce an immense amount of energy. 1 milligram is enough to take you to Mars, to take me and Adriana to Mars. So when will we be able to harness the potential of antimatter?
Hello, thank you for your question, thank you for invitation. So yes, I study particle physics, and all particles have an antimatter counterpart. Even chargeless neutron, we have antimatter. But unlike matter, antimatter is not so common unless we are upper atmosphere or inside a particle accelerator. We will not find antimatter normally in our life. In the beginning of universe, during Big Bang, we believe we had the same amount of matter and antimatter. And one interesting point is nowadays we can use antimatter for medical purpose. So there is one technology called positron emission tomography, or PET. It's a medical technique that we can detect cancer, measure blood flow, and detect coronary artery disease. So these scans, they use a small amount of radioactivity substance and they inject in our body, and this substance produce positrons, which are antimatter. And then these positrons will leave some image in our body so we can detect some health problem. So for now, we cannot use antimatter to go to Mars exactly, but we can use for help our healthy and detect maybe cancer or other disease. So I think in the future, antimatter can be really used for medical diagnostic tools and can be really interesting for humans to use science helping us to detect these kind of problems. Thank you very much.
Thank you so much, Gabriela. Now back to Anatoly. The Academy, the Mayak Academy, which is hosting us today, bears the name of Andrei Sakharov. He was one of the pioneers of thermonuclear synthesis, but neither he nor any other scientist was able to get this process under complete control. Mr. Krasilnikov, could you explain why is it so difficult to control the thermonuclear reaction?
You know, plasma is a very interesting matter. We know liquid, we know gas, we know solid state, and we also know plasma. Plasma is ionized gas. And thermonuclear plasma, fusion plasma, is special. Even plasma is special because a lot of very energetic particles inside. And these particles produce number of instabilities. And unfortunately, subject is so complicated that it requires time and it requires very hard activity of many scientists. That's why ITER is international project, because people decided that we all together should construct this machine. We all together should try to keep this plasma against instabilities. And this is major reason why we spend a lot of time and a lot of years to study and to confine this plasma. And, but this is question of confinement of plasma, but not question of safety. Because if we will have any trouble, we will have only slowing down of the process and we will stop plasma. No danger for any explosion at all. Internally, no reason for explosion. So internally, fusion energy is safety.
Which is very good. So now the next question is to Adriana, back to her. Humans are fragile creatures, as we can see. The key issue that makes interstellar travel impossible is the fact that a person wouldn't survive such a long journey. Russia plans to develop a plasma propulsion engine by 2024, right? And a prototype has already been made. Adriana, do you think a plasma propulsion engine could bring us closer to the dream of interplanetary and maybe interstellar travel?
Thank you for the question. So we watch a lot of science fiction movies and really dream of visiting other stars. But practically, let's go back. So in the early 1900s, Tsiolkovsky was considered one of the founders of rocket science, proposing the minimum speed for orbit around Earth and proposing to use a combination of liquid fuels in a multi-stage rocket in order to achieve such speeds. Let's fast forward to today, 120 years later. We are still using the same technology. So, can we reach the next level, perhaps for a plasma-based propulsion system, perhaps for an antimatter-based propulsion system? Perhaps. So there are proposals that if we can constantly accelerate to 10% the speed of light, we can get to the nearest star, Proxima Centauri, which is 4 light years away, right? Light takes 4 years. We can maybe achieve in one human lifetime to reach the star. But the communication to send the message to say we have arrived safely takes 4 years. So I would propose that we take it step by step. We need to dream. We need to continue to invest in fundamental research, because one day we do hope to have systems that can take us out of the solar system. But for now, as I have explained, since 60 years ago, I believe we have the tools to explore the planets in the solar system. And there are proposals for a plasma propulsion system to get to Mars in just more than a month. But in fact, a 6-month journey with the traditional chemical propulsion systems that were proposed over 100 years ago, we can do it. So this is what I am excited about, really using the tools that we have available. Because I think we should be careful not to dream that science and technology can solve all of our problems at some point in the future. At this point, we need to look at the tools that we have. And I think our ability to overcome the challenges we face here on Earth, the limited resources we are experiencing because of poor resource management, the tools that we have to explore beyond Earth to develop life support systems for our fragile bodies, including, as I've mentioned, shelter, power, water, food, communication systems. We have these tools. In our lifetime, we can visit Mars, live on the surface, return to the moon. Although we should continue to dream about antimatter systems that can take us to other stars. Let's also focus on the tools we have available to solve challenges of today on Earth, and the first step, the necessary first step, planet Mars.
Thank you so much, and let's get further to the tools that we are developing now. We know that before, countries used to challenge each other in the space race, fierce competition. And now we have a quantum technology race. Quantum tech is a sort of a holy grail. It has tremendous potential. Major states and companies invest huge amounts of money into its development, but our idea of what we're going to get is still pretty vague. Alexei from Moscow, from the Quantum Center, why is that the case?
Thank you very much, and first of all, thank you very much for the invitation. It's a great pleasure to be a part of such a discussion. And first of all, I would like to explain why quantum technologies are so interesting. Because quantum technologies are about controlling the smallest particles, smallest objects that we have in our universe. And it's not only about curiosity, but also about building new devices based on the principles of the controlling individual quantum system, like single atoms, single ions, single photons, quantum objects of light. And these devices helps us to provide communications which are absolutely secure, in a sense that the security is guaranteed by the fundamental laws of quantum physics, and build computing systems that allows us to solve the most complicated problems in our world. And for me, and in the spirit of this discussion, quantum technologies are interested because they can address some of the challenges that have been mentioned. For example, solve complex optimization problems that can save resources that we have on our Earth and use it in a more efficient way. And at the same time, we can simulate different types of the systems, including biological systems, new types of drugs, new types of materials that helps us to facilitate developments in other technologies, in atomic energy, in also space technologies, and many other fields where we have difficult computational problems that prevent us from the future, big step.
Thank you so much. You've mentioned medicine and biology, and now I would like to address to Ancha Baranova. Quantum algorithms could be used to model new pharmaceuticals and protein structures. Professor Baranova, hello, could you please join our discussion? What does this huge leap in processing speed with quantum technologies mean for medicine and biology?
Thank you so much for inviting me. What does it mean is that we will calculate all that we are calculating now much faster. 10 times faster, 100, 10,000 times faster, or million times faster. We will do basically the same tasks that we did before, but faster. We need to understand that quantum technologies are already here. Quantum computing, which we are putting forth right now, it's part of quantum technologies. Quantum technologies very often operate with images, and practically every task could be solved with quantum computing like image operation. For example, we can imagine in this space of quantum computing a molecule which would be thoroughly described like electron density and how exactly atoms interact with each other, and we can add another molecule and see how it is interacting with the molecule which we first put in the space. And because this is done much faster than right now developing approaches of molecular dynamics, we will be getting the solution not in the matter of weeks, but in the matters of hours or minutes. And that would advance the development of new medications, and we will have more candidates to test for new medications. But not only that, if you come back to the images, the known technologies like laser technology, MRI technologies, able to generate for us very detailed images. But right now, the limitation is in how fast we analyze those images and how fast we derive various conclusions from those images. If we are using quantum computing for doing that, we can use series of stacked images, for example, images of certain tissue. And when we treat this tissue or patient who has this tissue inside patient with new drug, we see the changes which are positive changes to this patient, not by some biomarker which is a couple of times removed away from this problem which we are analyzing, reflecting the state, but still very far away from the state. But we would be looking at the image and we see how beneficial changes progress through the stack of images. And those are applications of quantum technologies which are right here. They probably will be here already within 5 to 10 years.
Wow, thank you so much. If I'm not mistaken, quantum entanglement is particularly important for cryptography. Quantum technologies could put an end to online security breaches. I would like to ask Alexei in Moscow, what if this technology falls into the hands of cyber criminals? What's the plan for that kind of scenario?
Yeah, that's a great question. And first of all, I would like to mention that Nobel Prize in this year in physics was awarded for the studies of quantum entanglement, which is in heart of quantum physics and heart of quantum mechanics. Simply saying entanglement is a sort of correlation, strong correlation between quantum particles which feel each other because of their quantum nature. And yes, indeed, we can use quantum entanglement in order to build communication systems which are secured because of the fundamental laws of quantum mechanics. And here there is a kind of interplay between quantum computers that can break standard cryptographic algorithms and quantum cryptography which can secure us? And the answer is that we should protect the critical infrastructure of our world by using quantum technologies. Now, because we understand that in 5 or 10 years, we will have a quantum computer that will be able to break security of currently available cryptographic tools. That's why my answer would be we need to prepare now in order to have informationally safe future tomorrow.
Thank you so much. And now back to Beijing, to Dr. Liang. Today is UNESCO World Science Day for Peace and Development, which is held under the motto Basic Sciences for Sustainable Development. Basic research aims to uncover fundamental truths about our universe, while applied research works towards practical benefit. Seeking the truth is always a noble enterprise. However, Dr. Liang, how exactly do basic sciences contribute to sustainable development?
Thank you, moderator. Yeah, sustainable development is a collective effort that calls for transformation of our approach and behaviors at all levels of human society. So due to our impact on this planet, we must be careful in our approach to ensure that the mistakes of the past are not repeated. At the same time, we need to ensure that growth and development potential is not diminished so as to benefit societies around the world. Sustainable development is a common goal on a global scale, and therefore a global consensus is essential to achieve progress. Basic science will thereby help to develop a consensus based on measured, verifiable facts and drive innovation for more sustainable solutions. Through basic science, we get a more accurate view of the world we live in and imagine how we can make our societies more sustainable. So basic science can also help to promote understanding and communication between all stakeholders. It also can help to drive future innovations. For example, China established the International Research Center of Big Data for Sustainable Development Goals last year. So that center and other stakeholders concerned with the SDGs have put forward the idea that a community-based science approach could act as an effective way to search for new solutions to current problems. Because sustainable development is an unprecedented problem that faces each person on the globe, the new and innovative ideas, solutions, and more participation that basic science can provide are invaluable tools. Whether it be new development indicators and ways to analyze them, or innovative technology to reduce humanity's impact on the environment, there are many ways that basic science can support sustainable development. Thank you, moderator.
Thank you. Gabriela, the question to you. You also focus on basic research. Please tell us more about the importance of studying elementary particles, phenomena that currently have no application, while there are so many immediate practical challenges out there now.
Yeah, what I do is exactly elementary particles and basic science. And I think it's really important to know more about the behavior of these particles, if the particles we know nowadays in physics and the standard model of physics is the correct one. And the applications we can see, again, in medicine, for example, on cancer therapy, We have many X-rays, proton therapy, therapy with neutrons or heavy ions. And knowing more about these particles can help us in medical issues. Nowadays, around the world, we have around 7,000 medical equipments using particle physics and helping more than 30 million patients. Also on the industry, we can use our knowledge, for example, for cables that are made with superconducting materials that can make electricity moving more fast or the data moving more faster. Also, biomedical scientists can use particle technologies to understand more about structure of proteins or other informations that help us to understanding more biological process and healing disease. So I think particle physics is really interesting and we need to study more, and we can help humans in many ways understanding more about the behavior of particles. Thank you.
So, and now back to Ancha, to the US. The COVID-19 pandemic has demonstrated science's critical role, both basic and applied. Increasing resistance to antibiotics, cancer, genetic disorders. It's just a few risks in addition to new potential epidemics. Is modern science, and specifically its medical branch, up to the challenge? What tools are currently available to scientists, and what new means are there to overcome these threats?
Wow, thank you so much. This is great question, great question. And I should say that from the very first days of pandemics, scientists were able to pull through a lot of important things. They worked well 100%. I'm very happy with scientific output from the very beginning of the pandemics. But what happened, why we were not able to correct it in the very beginning and make sure that virus will subside and treat all the people and make sure that the disease is prevented and the rest of them, is the problems of costs and problems of acceptance for various new technologies in society. So it's not science which played the major role in how pandemics unfolded, but actually the educational component and economic component. And for all new technologies that would be coming after these pandemics, the problems, the obstacles, unfortunately, would be the same. It would be the problems of economics and problems of acceptance in society. So we need to work on those two a little by little, but technology-wise, the key for working with human diseases and overcoming those diseases is personalization. Right now, we do know how to treat one individual. If needed, we can prolong life of individual with cancer, with other illnesses for a very long time, but we need to scale up those technologies. The key is not in the new discoveries. We are really making those discoveries by millions and billions. We do publish much more papers right now about new compounds, including therapeutic compounds, new ways of therapy, about 10 times more than we did it 20 years ago. That is very, very important. But the obstacle is implementation, and this implementation is limited by costs and acceptance. Those two things we need to work on very thoroughly from now on for the next decade at least.
Thank you so much. I would just like to remind our speakers that you're welcome to join the discussion anytime soon. So if you have some comments on what your colleagues are saying, so please feel free to do that, okay? Now we will stick to the next, to one of our next guests, to Alexei again. The solution for global challenges we mentioned, be it pandemics, energy crisis, climate change, or whatnot, are only possible through the international exchange of experience, which entails the circulation of talent. This trend emerged in the late 90s in India, where the IT sector was booming, attracting home experts who immigrated to the US in the 70s and 80s. Today, IT companies generate roughly 7.5% of India's GDP. Alexei, how can we make returning back home more appealing for scientists and specialists?
That's a great question. I think that many countries that are now trying to attract talents are thinking about what will be kind of the best way to attract people and attract talents. And the main thing here is creating conditions. And conditions here means not only like financial condition or less bureaucracy, but also creating a critical mass of people working and thinking in the same direction. And many large projects, large-scale projects that are now being developed in Russia and in other countries show that making this critical mass of people locally attracts more and more talent. So we need to have a critical mass. And here I would like to mention an experience of Rosatom, a state corporation which created a roadmap on quantum computing in Russia, which helped not only to concentrate people in Russia to work on the problem, but also attract people outside and attract international expertise. And here I completely agree that in order to overcome global challenges, we need to cooperate. And these critical masses of people in different countries should communicate and create a network effect that helps us to understand and overcome the most difficult problems that we have.
Thank you. Adriana, Anatoly, would you like to comment on that?
Yeah, thank you for this question, very important question, and I totally agree with previous speaker. But what I should add that very important for young generation to have a great task. Not only salary. Salary is important, but very important in addition to salary to have a great task, to have a challenge and to have possibility to create something totally new, essentially new with respect to already known. And taking this into account, very important to create points of growing for technology, for science inside each country and in particular in Russia. And very important to have cooperation between Russian technology and scientific teams and other teams from different countries to understand that you are at the highest level of studies in the world. And this is the decision of the question how to create good condition, attractive condition for scientists to work here in Russian Federation, to continue their activity and collaborate together with our partners outside Russia. So sometimes we discuss how we should improve higher education, but to improve higher education, you should give perspective to students to work in a highest level laboratories or highest level team. If you provide him such condition, he will study very deep and with big interest subject which he devoted his life. And this is very important to create such condition here in Russian Federation. And we are trying to do this in the ITER project. We created 60, one time we calculated that we created 64 new technology centers, not world level, but higher than world level. And this is important for young generation to to belong to this activity, to belong to this team of people. And this is crucial.
Thank you so much, and you got a really successful experience in that, because your international project combines 30 participants from 30 countries, meaning that's a real circulation of talents for us. And I would like to address Anche as well. By talent circulation, we usually mean certain social phenomenon and its effect on global economies, like the role of tech specialists in India. And Anche, as a true cosmopolitan researcher, you speak perfect Russian, perfect English. What benefits or maybe harm do you think talent circulation can bring to science per se?
Well, this circulation, talent circulation, is a very important phenomenon. It is a cultural phenomenon. It is not economical phenomenon. It is extremely important for the development of the scientists, because they are not born scientists. They grow within certain scientific tradition. And they need to understand other scientific traditions which are developing in the globe. How science is done in Russia, in China, in the United States, in Europe is not the same way, but we need to learn to speak the same language, and everybody learns, and it takes time. We are not born as scientists when we are 20, 30, 40. We develop it in interactions with other people from other scientific traditions. In frame of large country, it is possible to achieve certain development when people from one part of the country talking with people from another part of the country. But when we are truly achieving international development, this phenomena is happening on the global scale. I would say it is extremely important for every scientist to be in process of scientific development, be embedded in some other culture. Not a particular culture, not like the best culture when they can get the best skills, but in some other different culture. And this is extremely important. If you think about it, we have 8.8 million scientists right now working on Earth. 8.8 million. And the science, like we know it now, is new phenomenon. Yes, we do have some classic scientists, modern scientists, which were living 100 years ago, and they were already within major scientific tradition, but the majority of the scientists were formed in the same time as we live. In fact, 90% of scientists who lived ever on Earth, they are alive now. So we are in very, very important moment when we are developing and transforming into some new understanding of the scientific culture which was not there 50 years ago and 100 years ago. And I think that this would be most transformative area in all parts of culture, of humanity. Of course, other areas would be transformed as well with new technologies, but scientists would not remain the same as they are right now. For example, we are talking a lot about AI, right? AI is very important. It would transform economy, would transform our daily life, etc. But think about it. We might have development of scientists who are based on AI, because in science there are a lot of routine works. And that would transform scientists in the generation of thinkers, because they would be freed of the routine scientific work on repeating experiments day to day, which is an important thing to learn, but it's not necessary to do it throughout the lifetime. So those scientists would be freed to become educators and thinkers. And this new image of scientists will not be possible without exposure to other scientific schools, to other cultures, and that will be necessary to form this new image of the future scientist, which will be coming within the next 5 to 10 years already, I'm sure.
Thank you so much. Adriana, do you agree or disagree? What's your stance? What's your vision of future of circulation of talents in the new multipolar world? Is the trend going up or down?
So for me, circulation includes interplanetary travel and cooperation. But let me go back to the name of my organization that I founded, Proudly Human. And perhaps not everybody feels proud to be human every day in this current era. So with that name, I have reflected on what is it to be human. Everybody can come up with their own description of humanity, but in English there are a lot of words that begin with C. So curiosity has driven a lot of our science, a lot of our technology, a lot of our exploration. The human need to be creative has driven the production of technologies that maybe have no application today, but in the future they have a very important and critical application. So I think we have demonstrated our curiosity and our creativity. But there's more. And let me say, I met cosmonaut Mikhail Kornienko, who has spent 1 year in space, the longest continuous period in space with Scott Kelly. And I told him of my dream to travel to Mars, and he said, firstly, you are crazy. Secondly, my advice is go with friends. Simple. So this speaks to collaboration. Yes, only together with all 8 billion of us or more can we create a future that we can be proud of together. And to do that, we need to add another word besides the curiosity, the creativity, and the collaboration, and that's compassion. Compassion. The ability to create collaborative teams where we have not only our own interests at heart, but the interests of all other humans and all other living systems, in fact, that we cohabit this planet and perhaps others with. When we go to Mars, we will not go alone as humans. We will bring bacteria, fungi, plants, perhaps animals. It will be a living system that we take with us. And this compassion, I think, is a fundamental part. Let me give a practical example. In the Apollo era, in the Soviet space program of the 1970s, we already developed power systems, nuclear, solar, etc. All of the power systems that we will need, even electrolysis for hydrogen fuel cells. Water management system. Today we have young children dying from unclean water, but we have water filtration systems developed for space stations in orbit around Earth in the 1970s. We need to distribute these technologies to all people on Earth and people living beyond Earth. Food production. Already in the 1970s, the Soviet program was growing plants in orbit around Earth. Food production. Suitable for city living in small spaces, suitable for space. So these are the basics, right? Clean water, clean air, power systems, food, communication systems we have. And with these technologies, I think we need to emphasize as we go forward that perhaps this is as far as we go without compassion. This is as far as we get when we are driven by curiosity and creativity. We will not progress further without collaboration and compassion, because only together, all of us, can we create a future that we can be proud of on Earth and beyond.
Thank you so much. And now, Gabriela, what's your stance on that? Can we hear Gabriela from Cuba? Thank you.
I think it's reading. Hi, I think it's really important, the talent circulation, in order to make scientists with higher background. I am someone that's studying 3 different countries at Portugal, France, and now in Japan. And I think this increase a lot my background, make me understand how other scientists work, give me the chance of working in a research field in Brazil we don't have. So I think it's important, and also important to create opportunities for students, like scholarships or financial helps that give this possibility for students to go abroad and be able to contribute with research in different countries, contribute with economy, and create a better environment for science. Thank you.
Thank you so much. Now I got a question to all of our speakers. So we're talking today about the practical implementation of breakthrough technology that is meant to make our lives better. However, every technology from thermonuclear fusion to genetic scissors or quantum algorithms, it's just a tool in our hands. And as we all know, people can use it for destruction as well as creation. So who should make decisions about the possible use of this or that technology? Scientists or governments? Or maybe we need some kind of public infrastructure like that of Hubble or the Large Hadron Collider. Who should own scientific technology and who should decide? Anatoly.
Really difficult questions. Usually those is owner who pay for development, and this is natural. In our ITER project, 7 partners pay, 35 countries pay. Who own? Everybody is owner of technology. And from this point of view, this technology belongs to some society of countries, society of scientists or engineers. And this may be a good example when technology belongs not to single country, but belongs to some group of countries. In our case, very, very wide group, kind of nations. I mean big nations, not small countries. And I think, of course, at this stage of our development, technology should belong to countries. But in future, we are going to the case when technology will belong to some societies of countries, societies of scientists, and this, in particular, in our case, in ITER case, who will make decision how to use technology developed in frame of the ITER project? ITER Council will make decision. ITER Council is include 7 partners, main like deputy ministers, so 7 big governments. And I think in future we will have very similar situation in many areas of science. And this is good development for me.
Thank you. And now we will give a floor to Alexei. I know he has to leave soon, quite soon. So Alexei, please, just a few words on that.
Yes, thank you. If I may first short comment about the previous question, I think that very important role of the scientific community is to adopt new technologies, because if we think about very complicated technologies that for the first time adopted by scientific community, for example, lasers were first a lab tool, and then they are around us in communication systems and etc. And also an example of LHC, like Hadron Collider. We know it because of its development in high energy physics and at the same time in medicine, which was mentioned before. But also internet, the tool that we're using now, was prototyped in such a scientific center. And now we see that in quantum technologies, scientific community is one of the main users. So it's a very important role of this large group of scientists that we have now. Speaking about regulation, I would mention Andrei Dmitrievich Sakharov, who maybe was the first great scientist thinking about this balance between these tools and their usage. And I think that we need to keep this example of a balance in creating any new technologies. And it's also, you know, the balance is a key word here. It should be balance of the responsibility of a scientist who open all the knowledge about the tool that he is creating, and at the same time the government that helps him to understand how to use the best sides of these technologies and keep many risks controlled and mitigated in the future developments.
Thank you so much. Thank you, Alexei, for joining our discussion today. I know that you have to leave for another discussion. Thank you for your contribution. And now the question goes to Ancha. Ancha, do you have any vision or idea? Is this kind of regulation even possible? The regulation we're talking about?
Well, it's a very, very tough question, as it was already mentioned here. We had developed about 150 years ago modern system of intellectual property, which was designed specifically to tackle this problem. And right now, 150 years later, we see the system in crisis. There is more to that, of course. There are many aspects of this, but we do not have a new system which we can put instead or somehow modify the system of intellectual property. Remember, in the beginning, I mentioned that the new technology adaptation was limited in the case of coronavirus by two things, by costs and by acceptance. The intellectual property system was developed to somehow tackle the problem of costs. So the owner of the technology would have incentives to develop the technology and implement it, and to do it as not very expensive technology so it could be sold. But it does not address acceptance at all. And right now, we are actually coming into understanding of this conundrum of acceptance and costs coming as two parts of the same problem. Because in part, for modern technologies of gene editing, for example, I hope that everybody heard about new drugs which were actually new technologies applicable to particular genetic diseases. They come into approval, but they are very, very costly. So yes, we can treat patients, but who will cover this treatment? Because it would not be possible just by patients themselves. So it is just one case which is treated and hundreds other cases which just cannot be treated within this frame. Well, the high cost for those technologies right now, because there are regulations, and all those regulations, lengthy clinical trials, etc., they all need to be figured into the costs. But we have so many regulations, so many regulatory obstacles, precisely because we have very low acceptance. If we will have better acceptance of the technology in society, so it will be seen as generally more safe, then it will not be so costly. So those two things, seemingly not related to each other, in reality are intertwined, costs and acceptance. So here scientists can help actually by being educators. Right now, it's not enough to create some kind of education program and roll it over to entire globe in hope that something will stick and somehow it will change people's opinion. No, it only works one by one. So we need a lot of personal educators which are, by their examples, be leading people, other people who are not that well versed in science, leading them into acceptance, which will bring down the costs. I think this is one of the possible solutions to this problem. But of course, you know, it's just my meager attempt or cracking very important thing which we really cannot solve as humanity. So let's try various kinds of solutions, and maybe one of them will help us with this. Thank you.
Thank you so much. And now back to Dr. Liang, to Beijing. So what's the Chinese approach? How China will tackle this kind of problem? Who should own the technology? Who should decide on that?
So this will always be a persistent struggle, and there is always a risk associated with new and innovative technologies. So I believe that both scientists and governments have their respective roles in the decision-making progress, and the contributions to developing effective regulations on technology and its applications. Personally, I believe that within digital domain, there might not be much need to legislations during development and research process. It's rather the deployment and implementation of these technologies that require more careful considerations about privacy and data breaches. Regulations and ethical science can certainly help to mitigate any concerns about the undesirable impacts. This is where legislators should work to protect consumer interest. One method that I can suggest is that governments can develop clear policies on ethical practice and develop a forum for regular national dialogue on communicating consumer concerns and protection with technology companies and researchers to ensure that any and all developmental process and end products are designed ethically from the beginning. So this will also help to ensure that these issues do not go unnoticed and there is a sense of vigilance among all stakeholders regarding these issues. So ensuring that strategies are in place to counter any adverse issues arising from these technologies. From an earth science point of view, because I don't know LHC and other physics, so I believe that the academics and experts in this field can be vigilant and play our part in mitigating risks. For example, in earth science, the most likely relevant risks are cybersecurity and privacy. What experts in our field can do is to help regulators and decision makers to simplify and streamline regulations and other measures, as well as translate the necessary information regarding new technologies and their potential for both good and bad in the simplest, most understandable way possible. Scientists then have the obligation to honestly follow the rules and the procedures that are decided. On the other side, regulators and decision makers should also look to engage experts to ensure carefully considered decisions to maximize benefit and minimize risk. Additionally, public infrastructure like LHC that you mentioned is another valuable area for governments and scientists to work together, because I think science looks to tackle global issues like climate change. Gathering public support and participation is a helpful idea. Particularly in earth science, this concept is embodied by platforms sharing open source data and science. A key part of the bigger data we mentioned, so it's a very good sample for this. Thank you, moderator.
Thank you so much for sharing your experience. Adriana, what's your personal point of view on that?
I won't add too much to my fellow panelists' answering of the tough question, but thinking about the theme for today, and perhaps space discussions seem far away, so let me refer to a quote by a Canadian philosopher, Marshall McLuhan, who said, "We are not passengers on spaceship Earth, we are crew." So with respect to the distribution of technology, I mean, with or without regulations, more than half of all humans have access to the global communications network now with a smartphone, with or without the regulatory systems. Even in regions without clean water, there is a mobile network or some kind of internet access. So this is a success and shows that perhaps in the future, technologies do naturally reduce in cost and become available to more and more people. And perhaps when we have access to fusion power technologies at home to water filtration systems at home, then we no longer need to consider the distribution of technologies, but the purpose. And the quote by Marshall McLuhan says, "We are crew on this planet." So at some point, we need to think about why we are innovating. And the most important reason is to protect our life support system. This is the natural environment on currently only Earth. So I think the focus on the distribution of technologies with the equity around the Earth, as we have heard, is critical. Perhaps we get there with or without the different regulatory systems, but why are we innovating? And I think it's important to see our role as humans as part of the living network that we are part of here on this unique planet Earth, the life. And then perhaps we can start to really focus on using our technologies to protect this unique planet that we live on, and excitingly to explore beyond it.
Thank you so much, and I would like to thank all of our speakers today. So our discussion began with humanity facing a number of pressing challenges, and unless we do something about them, they will materialize into some real threats. But you cannot really tackle a challenge unless you understand it. Listening to all of you today, I'm once again convinced that science is indeed a torch that illuminates the world. And scientists play an enormous role in broadening our understanding of this remarkable and fragile planet. The picture you all painted today of the future is complicated. It's not going to be easy, but I'm thinking I would be delighted to live this kind of future, because science is already opening up dazzling new horizons for all of us. And who knows, maybe one day, soon, quantum computers will help us figure out how to use charmed mesons and whatnot. So thank you so much for this experience today, for this discussion. We're not yet through. We're now sticking to the next part of our discussion when we can hear the questions from the audience. Я перейду на русский язык. Сейчас та часть...
I shall switch to the Russian language. Now is the part of the discussion where we can address the questions from the audience. If anybody of you have questions, ask and I'll translate.
Наверное, вот микрофон.
I believe, yes, the mic is on the way. Yes, I have a question to Adriana. I have a personal one. So, you were planning to fly to the colonizing mission Mars 1. Tell us, weren't you scared of not coming back to Earth?
I will translate. So the question is to Adriana. You're willing to go to the Red Planet as part of Mars 1, a Mars colonization mission. So weren't you somehow afraid or scared by the prospect of never being back to Earth, of never returning back?
So thank you for the question. The Mars 1 project unfortunately didn't raise enough money, so I established Proudly Human to start to prepare the kinds of teams and the kinds of technologies to survive extreme conditions on Earth, importantly, but also at the same time beyond Earth. Just to quickly summarize. So the fear of the unknown. So a quote that I often use is, "The allure of the unknown, the attraction of the unknown, to me and to all of us, I believe, is more powerful than the fear of the unknown." And, you know, many people have said, aren't you afraid to die on Mars? But let me remind all of us that the one guarantee in life is death. And what greater way to celebrate life than to do what no one has been done before. As Anatoly has said, we need these grand adventures, these grand visions to strive towards, to aspire towards, in order to keep us enthusiastic about the future. And I think this is what Elon Musk billionaire helpful is saying with his endeavors to build the transport system to Mars. We need to feel excited about the future. And for me, the idea of living and eventually dying, exploring, doing what no one has done before, and sharing this excitement about the future with people back on Earth or my fellow community members on another planet, perhaps, would be the greatest way that I can think of to spend my time in this reality.
Thank you so much. Пожалуйста, еще вопрос.
Yes, please. Another question. Hello. Julie Ruda, a scientific journalist and an editor from Vesti.ru. I have a question. Let's imagine a future where we already implemented this ITR project in, let's say, for entire humanity. So everybody has access to unlimited pure energy. How would you see a balance of power in that scenario? And I have a question to Anatoly Krasilnikov. Can we imagine already that we're going to have, a reactor on the surface of Mars that will also supply energy to Mars colonies? Is that realistic to upscale it to Mars or downscale it and transfer to another planet?
So the question was, let us imagine the nearest future, the thermonuclear fusion. We did like some success in this, and can we imagine how this success will be developed? For example, can we use it on another planet or whatnot?
I don't know in Russian or in English better.
Better English.
Okay. Okay, let's imagine in 15 years ITER will be successfully operating. In this case, what will be the main result? Main result, we will have knowledge how to produce this plasma, how to keep it long time, and how to arrange a reactor from this plasma. This is one result. But another very important result, 35 countries will understand how to work together, how to understand, how to produce new knowledge together, how to live together, create something new together. This is very important, not only for fusion, for all civilization. This is important. And of course, after this, we'll start next stage. We will start to think about how to use this knowledge, I mean fusion, in space research, in space traveling, in other application. So, new generation of new knowledge never finished. So we will continue. But what is very, very important, we will be joined. We will be a team of different nations working together and ready to produce something new together. This is main results, and I imagine this very, very good results from ITER project or CERN project of space station project. This is very, very important for us to change from today's status to next status after such big and very important projects in science.
And if I understood correctly, can this technology be exported to other planets?
Exported to?
To other planets.
Yes, of course.
Theoretically.
Of course, yes, but first step, of course, we should make here on our own planet. But of course, this will open our, our civilization definitely will go to the space, to the moon, to Mars, to other planet. And to do this step, you need energy. Because you can't use existing energy, coal, gas, oil, to do this. You need something totally new source of energy. And hydrogen isotopes, which we use in fusion, very convenient for this. And this is one of very big importance of fusion for next development of our population from the Earth to outside the Earth. This is clear for me.
Wow, thank you so much. Еще вопросы, пожалуйста.
More questions, please.
Добрый день, Андрей.
Good afternoon, Andrei Chernevsky from Eleron. Could you please tell me, at the start of the discussion, Adriana, I think, mentioned this about using plasma engines, and maybe it was a translation mistake, but we talked about light speed. Was that an error, or is that really true? If it's a error, then what sort of speed are we talking about here? If it's not, then it's opposed to Einstein theory.
The question is to Adriana. We mentioned the plasma propulsion engine. So, and the way, what kind of energy it uses. Вы по-английски говорите, может, вы поможете, да? Что вы имеете в виду? По световым, как называется световая? Сверхсветовая. What kind of speed you can achieve by using this plasma propulsion engine? Is it like? Can you explain, right?
Yeah, sure. So I will not go into too much detail. I think there are many experts on the Russian development of the plasma propulsion system. And there is a company in the US by astronaut Franklin Chan Diaz called Ad Astra, who are building, these are what I'm aware of, building a plasma propulsion system. So you're still using fuel for the plasma propulsion system, but you are using it much more efficiently. This, then, it is possible to accelerate for longer periods. So at the moment, we leave the surface of Earth, we reach a maximum speed, 30, 40, 50,000 kilometers per hour. Then we turn off the engines because there's no more fuel, and we continue, use some fuel to arrive and land. It's basic. If we have the plasma propulsion fuel, we can accelerate halfway to Mars at 1G. Good for the body. We can experience Earth gravity accelerating halfway, realign the spacecraft, decelerate for the second half at 1G, again good for the body, and in this way we can reach Mars in 39 days, is the proposal. So basically the reduction in the amount of fuel enables us to constantly accelerate for longer periods, and there are even more exotic proposals to accelerate to Proxima Centauri, 4 light years away, and perhaps to reach there in one human lifetime. But the speed of light is still not on our side. It is fast, but not very fast enough. In order to send a signal back from Proxima Centauri to Earth is still 4 years. So we have a lot to do here on Earth before we can start thinking about communities living 4 light years away. And this is why it's critical to invest in fundamental research that we are not yet aware of the application, because at some point we need to revolutionize our understanding of space-time. Because only if we can travel faster than light, which currently we do not understand how to, can we really begin to explore. So let's use the tools we have available to us. Let's support our colleagues who are investigating things that we do not yet have applications for, because with these 2 tools together, we can explore the solar system for sure, and perhaps in a few generations, even beyond.
Thank you so much. Пожалуйста, еще вопросы?
Yes, please, more questions. Hello, my name is Alexander Ivanov. I'm an engineer technologist. I'm a science communicator. I have a question to Ansha. Can we create sort of a friendly virus that would help us combat various diseases? Let's say that it would work in our favor, not against us. Thank you.
The question to Ancha. Is it possible to create a friendly kind of virus or a good virus that will be on our side and that will help the humanity to struggle with bad viruses?
It's a very good question, and the answer is real simple. Those viruses already made. Those are vaccines. You know, some of the vaccines are live viruses. For example, vaccine against measles is exactly this good virus, which helps us to overcome real bad virus, because measles is more infectious than coronavirus. And if we would have measles pandemics of the same proportion, that would be worse, really. But friendly measles vaccine helps us to fight this, and that is great. But of course, it has been since then developed further. There are some experimental systems of friendly viruses which are able to specifically fight other viruses. Right now, those are just experimental papers which are in vitro or at the very beginning stages of animal experimentation. They are not in human yet, but that is real good development. And the number 3 is phage therapy. Of course, phages are viruses. In this case, they are not treating human cells, but they are treating bacterial cells. They're trying to help us to get rid of bacterial infections without antibiotics. And they're having great applicability. And actually, Russia and Georgia are 2 pioneer countries in this particular area. And right now, those therapies are being picked all over the world by other countries. So that's one of the great examples of friendly viruses. And I'm sure there are more, and there will be more.
Thank you so much. Да, пожалуйста, еще вопросы?
Yes, more questions, please.
Добрый день.
Good afternoon. My name is Mikhail Urbaliev. I'm a student from the branch of MSU from Sarov town, and I have a question to Professor Dulin. So here's my question. So do all digital data about our planet should be open for public access, or maybe some of that data should be encrypted?
So now we would like to address Dr. Lian from Beijing. So you are dealing with big data. What do you think? Is all the big data, all the scientific base should be open? Should have this open access to all the people who are interested in it, or should it be restricted? The access to all those big data.
Thank you. So, thank you, moderator. Thank you for the question. So, UNESCO released the open science recommendations last year. And one of the key components of the recommendation is open data. So, I think 20 years ago, people asked me what a digital Earth is. So people think digital Earth is put the Earth into the computer. But now, in the big data era, I think it's big Earth data. So I agree with the speaker said science is the same language. Yes, that is the same language for all of us. So if you want to go fast, then you go along. But if you want to go far, then we need to go together. So people need to open the data, but under the ethical restrictions. And we need to share our data for pushing forward the science development. So people think we are now in the scientific data-intensive paradigm. So we need to use data to find the scientific discovery. So I think we need to open data. So that is a way to make our science better than better. Thank you, moderator.
Thank you. Thank you so much. Пожалуйста, еще вопрос.
Please, more questions.
Alexey Agnew.
My name is Alexey Agnew from Troitsky variant of Science newspaper. Sorry, I'm very nervous. Sorry, correct me if I'm wrong.
For all speakers, but especially for you, maybe. What is the source of your faith in humanity? Yes, about the C letters. Yes, to be human means not only to be curious and creative, but to be cruel. Yes. And the motto of our discussion is science for peace and development, but now is the time of war, one of the greatest war in the 21st century. And I see the photo of Andrei Sakharov, Nobel Prize winner, but we know that Nobel Prize winner of this year, Memorial organization, was destroyed by Russian government. And Novaya Gazeta newspaper, Dmitry Muratov, the Nobel Prize winner of previous year, the newspaper was destroyed. So what is the source of energy? The question for all speakers, but especially, yes. What is the source of energy for you now? And what is the source of your faith in humanity? Thank you. Excuse me for my question.
Да, но вы просили вас поправить. Нас, конечно, вопросы
Yeah,
касаются...
but our questions pertain to the scientific world.
So please feel free to answer. If you would like, you can stick to the scientific part of the question. Thank you.
If anybody else would volunteer, please. Yeah, thank you for the question, a serious question, but let me go to physics and say, back to the Big Bang, you know, without darkness, there's no light. Without vacuum, there's no matter. And without cruelty, there's no compassion. So it is each of our choice, I believe. And this is why it's important that we each have the tools. The technology is distributed, because with this technology, for example, I can be an individual power for good or not for good, but it's my choice. So I think another aspect of being human is aspiration. We are always striving, aspiring to be better. And it is our choice whether we go towards one direction or the other. But now we have the tools. We have the tools. We have many tools. Now we need to consider how and why we use them. So, of course, not every day do I feel enthusiastic about humanity. But more than half, let's say, we have to be a source of good, a source of light. Otherwise, for what? You know, I think positivity is the only logical way to live. Otherwise, you give up. So if you are waking up in the morning, living your life, looking at things like quantum entanglement, we don't know what impact we have on the people around us in ways that physics can't even describe yet. So it is our duty to be positive, to be a light of inspiration for people around us. Maybe someone else is not having a best day, then it's our responsibility to encourage them. So this is a simple answer.
Thank you so much for your answer. I think that's the crucial thing. You have to be positive, to be creative. Otherwise, you can really make a lot of plans and not achieve anything. So I would like to sum up on our discussion right now. Thank you so much to all of our speakers. Thank you so much to our audience for your questions, for your time. And let us not forget that we all live in a very difficult but very interesting time. This is the time of great shifts in geopolitics, in science, and I feel really excited on the future, which is about to come. And I think that the greatest things, the things we're gonna discuss in some 5-10 years will happen right now in science specifically. So thank you so much for your attention today. We're now through with our discussion. So, and we're looking forward to the next discussions quite soon. Thank you so much.